Hello everyone, my name is Viraj, and today we'll be discussing the 10th problem from the CP-31 sheet by TLE Eliminators under the 900 edit questions. Let's go. So I'm moving on to my sheet over here, ticked off 900, and the 10th problem, odd queries. Let's read this. You have an array A1, A2, so on till AN, and you have to answer Q queries of the following form. If we change all the elements in the range AL to AR of the array to K, then will the sum of the entire array be odd? Note that the queries are independent and they do not affect the future queries. Okay, let us generalize this problem. A very, very short problem. They of course start with saying that I have an n-sized array given to you. So n is the size, let's say array A is there from A1, A2, A3, so on, so on, so on, till AN. And then what they are saying is you will have basically Q queries that is given to you. Each query will be of the format L, R, and K. So let's say I have some query L, R, and K. Now what are these variables? What do they represent? L and R basically represent left to right or sort of a segment from this array. So maybe let's say this was like A4, let's say this was A5. So maybe the query looked like 3, 5, and 2. So I'll basically take all the elements in consideration from A3 to A5. This is actually this 3 to 5 range L to R. And then what's the question? The question is, if let's say these elements right now are A3, A4, A5, whatever these are, whatever their values are, let's say I actually change these values to K, every value. A3 also becomes K, A4 also becomes K, A5 also becomes K. When I have done this, and then I calculate the sum of the whole array. So let's say the sum of the whole array right now is S. The question is, do you think that this sum is odd? Is this odd? If you think that yes, this sum is odd, then your answer is simply going to be yes, else your answer is going to be no. So this is a yes, no based problem. And such queries, that is like this is sort of a one query that I showed you of LRK. You can have more queries like this, that is basically the Q number of queries that we'll have. And they've given you a very important line that queries are independent, as in they do not affect future queries. What does this mean? Let's say you have processed this query number 1 and you say, okay, A3, A4, A5 changed to K. Now, next time if you process some another query for which there is some different L, R, and K, these values of previous K will not retain. So the array will go back to its initial position and you will start ultimately from 0. So A3, A4, A5 will retain itself to whatever value they had. So making the changes don't affect them. This is a very important point because this might create some sort of confusion. So this should be clear. Every query is independent of each other. Okay. So yes, no to every query. This is what we have to report. And let's go to some test case. And I think that should be clear if we analyze some test case fast. So yeah, you have 5 as the size of the array, and that is 2, 2, 1, 3, 2. And then this 5 extra variable that is given is actually the number of queries Q. So you have 5 queries. You can see you have 5 queries: 2, 3, 3, 2, 3, 4, 1, 5, 5, 1, 4, 9, 2, 4, 3. So let's analyze this quickly. The array is 2, 2, 1, and then I have 3 and 2. Okay, great. So this is 3 and 2. Now, of course, I'm talking about elements from like this is 1 based indexed. So I have element marked index 1, index 2, index 3, index 4, and index 5. Okay. Now the first query, 2 to 3 changes to 3. That is, these two elements change to 3. So this is also 3, this is also 3. Now let's find the sum of this whole array. 2 plus 3 plus 3 plus 3 plus 2. The sum of this is, of course, you can say 9 plus 2 plus 2, that is 13. Now, is 13 an odd number? Of course, it's an odd number. So that is why I'll say the answer is yes for this query. Next time, 2 to 3 and 4. So you will retain back the original array. You will say, okay, fine, just let's remove this. And now these numbers are actually 4 and 4. Now, if you calculate the sum, 4 plus 4 is 8, then plus 3 is 11, and then you have 4 again. So that's 15. Is 15 odd? Of course it is odd. So next answer also turns out to be yes. And then you can similarly calculate within pen and paper all the answers to the other queries. They're going to be very straightforward and very, very easy to imagine. Similarly, you can also figure out the test case number 2, and you will understand the answers are no, 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 and the last case is yes. Okay, so very, very straight and very simple question. All we are trying to understand is, does the sum changes to odd after you modify some segment to have all elements to be K? That's all. Okay. Great. So I think we have understood the problem. Now let us actually go to a very important concept, that is, what's the expected time complexity in this problem? Okay. So in this problem, I have been given time limit per test as 2 seconds. So I know that 1 second basically allows me 10 power 8 operations. Okay, so because in one test I've been allowed 2 seconds, this is basically 2 into 10 raised to 8 operations. Okay, 10 raised to 8 operations allowed. Now, if I go back over here, I know that in one test there are some test cases that is in 10 power 4 order. So technically I should talk about number of operations for every test case, but there's an important line over here, that is the sum of n over all test cases don't exceed 2 into 10 raised to 5. That means like if I accumulate every test case together, overall the sum of n is in 10 power 5 order. So maybe I should not take number of operations for every test case. Rather, with every test, that is 2 into 10 raised to 8 operations, something I want to compare of a solution I make, since overall on a larger picture, it will work for every test. Okay. And this is same applied to Q also, because Q also doesn't exceed 2 into 10 raised to 5 order. So over here, my discussion ends and I say, okay, one test is allowed 2 into 10 raised to 8 operation. So now I can focus on n being in 2 into 10 raised to 5 order, and also q being in 10 raised to 5 order, 2 into 10 raised to 5 order. So now, because this question has a query based sort of a structure, so typically in this question, we can expect that we create a solution that either looks in order of O of n, or it looks like in O of q order, where we are able to process the queries or something. The point over here is, since I have a 10 power 5 order, if let's say both are the highest values, that is in 10 power 5 order, and I just take n into consideration right now, just to show a order of what sort of a time complexity expected, we can create, of course, an O of n solution. Maybe we can even create a solution that looks like log base 2 or n log base 2n. That also works. But as soon as you go in like square orders or above, this is going to be a problem. So even if you create something like n into q or n square or q square, all those square orders are not going to work, because then you create a solution that looks like 10 power 5 raised to 2, and that is when you exceed 2 into 10 raised to 8. But if you are in this n log order or directly n order or q order, and anything below this, even if you are able to create solutions that looks like constant time complexity, you are good to go, because all these orders work. Okay, so this is a very, very important discussion, and this sort of tells me that I cannot create ideas that are very brute based, because square solutions are somewhat brute solutions. So I need a very optimized solution in this, and this is where the main idea actually in the problem will lie. Okay, we will see this later on. So this is sort of an upper bound. Okay, great. So now that we have understood that we want to create something of a log n or something like an O of n or O of q sort of a solution, we can analyze this part also, that is what is required in the problem. Because if we do this in a brute manner, if I approach this problem in a way that I say, okay, you had q queries, let's just start processing every queries. So maybe I'll say I have a for loop, like I'll have a for loop to process the queries. This for loop starts with goes in a limit of q, so like 1 to q, and inside this I take the input of L, R and K. Now a very brute solution that comes to mind would have been very simple. I would have said, okay, modify the array, let's maybe create a copy of the array and then modify whatever is coming from range L to R, and then just modify that element to K, add everything up, and that's your answer. That's a basic check of odd and even, print a yes or no accordingly. But to do that, if you run another for loop inside this outer for loop array from L to R in this range, remember you are going to reach a time complexity that's in sort of a square order, right? So typically this would be like n into q, which is approximately 10 raised to 5 into 10 raised to 5 order, or 2 into 10 raised to 5 into 2 into 10 raised to 5 order, if you talk about n and q being both large limit. Why? Because it can happen that maybe you have a query which has L and R to the very extreme ends, and then n is also very large, q is also very large. So you will be processing a lot of queries in a very high time complexity. That means n into q is sort of not allowed. And why did I take an expected time complexity discussion is because this is hinting me very strongly that if you're creating a solution that looks like n into q, this term over here, that is into q order, is something you cannot eliminate, because you will have to process the queries. You need the values of L, R and K. So this is something you cannot eliminate. But the extra time complexity that is coming from this n order, where we are actually going to each and every element and modifying it, is something we can work on. And this is where the whole idea of the problem lies. Maybe we can optimize this, and if you're able to do that, maybe our whole time complexity gets less than this, and we actually run every query nicely, and we're able to get our yes or no answer for every query. Okay, so this is the whole idea. Optimize this somehow, as in, to be very specific, optimize how would you calculate the overall sum after a modification in the array quickly. If you're able to do that, great, good to go. And this is where the whole idea will lie. So to solve this problem, we will have a small prerequisite. We need to know something known as prefix sums. Okay, so this is a very known and very good concept that is used multiple times in problems in this rating. And what is this concept? I'll give you a small brief. Let's say the array looks like, so let's say I have an initial array and the array elements are simply A, B, C, and D. So what does prefix mean? Prefix means basically from the left. So you'll start off with them left, and sums means you're taking sum. So what you'll say is prefix sum is also an array of same size, and the values in this are filled according to the sum till that location from the left hand side. So basically this value becomes A, this becomes from the left A plus B, this becomes A plus B plus C, this becomes A plus B plus C plus D. This is what happens. Now, your argument would be, why am I using this? Why are you saying prerequisites is a prefix sum in this question? Is because our main idea, which we want to lessen our time complexity, is how do we calculate sums in a segment quickly? If I know, like if understand this, if let's say your array is given and somehow you're able to get the sum from L to R quickly, what will happen? Imagine this. Let's say I'll take an example. Let's say your numbers were A1, A2, A3, A4, A5, A6, let's say A7. I had just 7 numbers. Now let's say I tell you that this is the range A3 to A5, which you have to modify to K. So how can you get the new sum very quickly? Is that if let's say you know that what's the overall sum, current overall sum, let's say that is S. That is, or you can say this old sum. From this old sum, if I subtract the sum that is in this range, A3 plus A4 plus A5. So I'll call this segment sum, something like this. Segment sum. And I add back. What do I want to add back? If let's say these elements of sum cross out, what do I want to add back? I want to add back 3Ks. How do I get 3Ks? Basically 5 minus 3 plus 1. Or to be very specific, this would be L minus R plus 1. This is basically the number of elements in this range. So basically R minus L plus 1 is the total amount of elements you actually get in this segment into K. Very simple, because if every element becomes K, then in all the segments, you basically want K. How many number of times? L minus R plus 1 number of times. So overall, this value can be your new sum after modification. And to get this new sum value, you want the old sum, which is fine. You know the old sum, you can like pre-calculate it even before going in your main logic. This is just something that doesn't modify itself. This is almost a constant. But this, and even this, sorry, I'll comment on this part also. Even this is pretty much easily calculatable because you know L and R values and you know K values. You just need to plug this in the formula. But this is actually a problem. I'll mark this with red. How do you get the segment sum? How do you get A3 plus A4 plus A5 very quickly, even without iterating? Remember, this is what we were actually iterating, because of why we were getting this extra in complexity. That is why prefix sum is helpful, because if in prefix sum I ask you, what's the, let's say, just the same logic. Let's say I want to calculate the sum from this range to this range. How does prefix sum help is, prefix sum says, because of how I have stored values in my array format, you can get the sum totally till R, and from that you can remove the sum that comes till L minus 1. And if you do that, you will actually come up with the segment of sum which you wanted. See over here. The sum till, I'll write with green pencil, the sum till C in prefix sum value would be A plus B plus C, that is stored at this R range. Since this is L, this is R. So A prefix of R would be A plus B plus C. From that, if I subtract, what do I want to subtract? A of L minus 1, sorry, prefix of L minus 1. So prefix of L minus 1 would be this value, that is A. So this is L minus 1. So I'll subtract this, A. What do you actually get? You get B plus C. And this is not, and isn't this what you wanted? Of course, we wanted a segment sum. We quickly got it. So you can understand this idea that prefix sums is something, some sort of a concept which is very helpful if you want to calculate segment sums. And because this problem required you to calculate segment sums quickly, since if you would have not done them quickly, then you would have this extra n complexity, prefix sums becomes a very, very important topic in this problem. Okay, it becomes sort of a prerequisite actually in this problem. Okay, so I hope this is clear. Now what we can do is actually we can run some sample case quickly so that we are able to analyze what do I mean when I run the prefix sum order. The same test case, or maybe I'll take the different test case. Let's say the same test case. So I have 2, 2, 1, 3 and 2. So what I can do is I can calculate a prefix sum array out of this. So this becomes 2, this becomes 2 plus 2, 4, 4 plus 1, 5, 5 plus 3, this is 8, 8 plus 2, this is 10. So basically this is the prefix sum array now. This is the main array, this is the prefix sum array. Okay. Now let's say I'm processing the first query, 2 to 3 and 3. So what I'll do is I'll say, okay, all the sum till 3, so this is the next 1, 2, 3, 4, 5, minus all the sum till 2 minus 1, that is 1, get that. So this segment sum actually, like segment sum, previous segment sum basically, when you have not modified the array, turns out to be simply 5 minus 2, which is 3. And you can see, yeah, this is 3. 2 plus 1 was 3. Great. What is the like new sum that you want to fit in? That is like from the previous formula, L minus R plus 1 into K. So this is basically 3 minus 2 plus 1. That is the 2 elements total. And every element becomes K. So basically 2 into 3. So you can say L minus R plus 1 into K becomes 2 into 3. That is basically simply 6. And what was the old sum? That was the main constant sum. That was initially in the whole array, the sum was 2 plus 2 plus 1 plus 3 plus 2. So this was basically 10. So the old sum can be written as 10. So now just plug in the values. 10 minus 3 plus 6, this gives you 13. And is 13 odd? Yes, it is odd. Print a yes. Great. And do you think you have calculated this yes answer pretty much quickly? Yes, you have, because if you pre-calculated this prefix sum array without even going in the while logic, sorry, the for loop logic of this 1 to q for queries, what will happen is if this prefix sum array is already storing whatever values are there required, then inside this you will just have to take L, R, K input, calculate the values and simply check if it is odd or not. So this pretty much inside this would turn out to be constant, which would make this whole logic of this for loop turn out to be simply O of Q. And this is the optimization. This term no longer is there. You have turned this to be 1. And now will this work? Of course this works, because now you've created a solution that looks like O of Q. Then again, the outer prefix sum calculation would be like O of N. So you will get a solution that looks like O of N plus Q. Now n plus q is fine because n and q both are in 10 raised to 5 order, and we know by time complexity rules that n plus q basically would be adding up. So if they're adding up, they will be considered separately. Whatever is the major term right now in that test case will take over. Maybe you have 2 into 10 raised to 5 as n and q was smaller or q was bigger, that doesn't matter. But overall this order will still remain in O of 2 into 10 raised to 5. Okay, and this is where the problem will get solved. Of course, this is less than the 2 into 10 raised to 5, 2 into 10 raised to 8 operations we wanted. So great, good to go. My logic is right, and I'm going to get an accepted solution. Okay, so very, very fundamental sort of a piece of knowledge that is there is prefix sums used in this problem. And you should definitely check this sort of a topic out, because this is very, very useful in ratings like this and above. Okay, so let us look into the code part now and see how do we do this. Very simple. Take the test case, then take the n and q variable, then take the input of the array. Then I have a sum variable, that is the old sum. Basically, I can modify this. So this is like the old sum I have of the array. Okay. And then I just run a for loop to get this old sum. Then I have a prefix sum array. Now I have initialized this to be n plus 1 size. Why n plus 1 size? Because that would give me indexes from 0 to n, and everything is initially 0. Why have I done this is because I am following a 1 based indexing, since L and R were also given in 1 based indexing also. They were from 1 to n. So it's very simple for me to calculate now. I'll just say run a loop from 1 less than equal to n. Prefix sum of 1 or I at that moment becomes I minus 1. That's the previous sum, whatever is stored at that location, plus A of I minus 1. Why I minus 1? Because I would go to equal to n. So I minus 1 would be n minus 1. And remember, in the array, you don't have a 1 based indexing. Array is 0 based index. So basically, this helps you retain a prefix sum array of a total size of n locations, but you will only be using the locations, n plus 1 locations, but you will only be using the locations from 1 to n. Then you run a while loop simply on q, or this could have been a for loop, basically just iterate in q times. Take the input of LR and K. Then what is the sum you want to remove? That is prefix of R minus prefix of L minus 1, right? Now this is very, very important. This is the sum I want to remove, or the segment sum that is present already without modification. The sum that I want to add, what is that? L minus R minus L plus 1, that is the segment size into K. And then what is the new total sum? That is old sum minus the sum to remove plus the sum to add. Now, if this total sum I feel is odd, I'll simply print yes, else I'll print a no. Okay, fun problem. Let us discuss the time complexity. N order, simple. N order over here to calculate the sum, and very, very simple N order over here to calculate the prefix sum. Now, inside this is Q order, and inside this, everything is constant. This is pre-calculated, this is pre-calculated, this is pre-calculated. So very, very simple. And that means the overall time complexity turns out to be O of n plus q, which means it is like O of 2 into 10 raised to 5 order. Okay, and what about space complexity? Space is again dependent on the size of the array, and I'm also using one more array that is of the prefix sum array. So it's basically O of n only. That's the maximum size I'm using, which is in 2 into 10 raised to 5 order again. Okay, so overall, this problem is now completed. Prefix sum was a main prerequisite in this problem. I hope you like it. Thank you for watching.